Welcome to today's ArcGIS tutorial. I'm Abhudip share with you. I'm from Pune University of Engineering and Technology. Today we will learn about heat map. So here we are given a scenario where people died because of cholera and the disease is related to location of any local pump. Now we have to determine which pump is responsible for the most number of deaths. Before starting any of the work, we need to change the symbology of the points so that we can have better visualization. So for the dates we'll use these points, and for the palms we can use red color like this. Now according to our experience of the previous tasks, we can say that IDW interpolation technique can give us some clue here. So we are going to apply it over the shapefile of color dates. Let's search IDW and then just select inputs. It will take some time. Now in the z field value we'll use count. Count is the count of deaths, so we'll use count. And for the output raster we'll go to the project 6 and we'll name it IDW death. We will accept the default cell size and power. Everything is done almost. We can now click OK and see what happens. Now you can see there is this interpolation. Now we can see the extent is covering 4 of the palms. 1 2 3 4. So we are not sure about the palms which is responsible for most number of deaths. For this kind of scenario, we have another tool called kernel density. While IDW is only focused on the distance between the points, kernel density is more focused on the change of density. Here the number of deaths will represent the density, so let's apply kernel density over cholera shapefile. First we'll search for it, kernel density. So this is the tool. In the input we'll select cholera deaths, population field will be count. Then we'll save it as kernel death. Okay, the cell size will be default and all the options will be remained as default. Then we'll click OK and see what happens. Now if I change the symbology, this thing, let's see, we can give this one or this one. Let's say we give this one. Now it's looking a bit harsh. We can just simply change the display to bilinear interpolation for better visualization. Now it's looking better. Now if you look over here, there is a pump and here the death toll is the highest. So with this visualization we can easily identify the pump which is responsible for the most number of deaths, whereas in the IDW interpolation we cannot surely say that this pump is responsible. So here the kernel density works better. Now that we have learned the kernel density, we will move to another project, that is nighttime light heat map making. So for this task we will need a tool, that is ISO clustering. So we'll search for it. this is the tool, ISO cluster unsupervised classification. So in this tool, if we just take it here, and number of classes will primarily give 2 and save it as cluster 2, and minimum class size will just keep it as it is. Then we'll click OK for the heat map generation. You can see that there is this color. So the blue areas are representing the area where the light is more intense. We can analyze one more time with 4 classes. If we give 4 classes in this time, we just use 4 classes with same files and same options. Now uh, to compare these two rasters, we just have to just rename it for working with it. Cluster 4, this is 4 class and this is 2 class. So the both layer needs to be of similar color. If I give yellow and I need to give something deep, let's say this one, and for this we'll select the same colors. This is not the same color, I guess, more darker. Now it's okay, and here we'll give the green. Now you can see the change, but the change can be shown more perfectly by using our image analysis tool. For that, we'll just go to Windows and image analysis. Now the upward thing is cluster 4. If we select this swipe layer button, and then you can just go from upward to downward, you can see the change that is occurring. While we are on the cluster 4 layer, the colors are more spread, and while we are on the cluster 2 layer, the colors is a less spread. This is the difference between these two cluster or heat map. So this is it. So we have one final task left for today, which is visualizing netcdf file. For that task, we have to search netcdf first, and we will select make netcdf raster layer. Now we need to input the netcdf file that is here. It is a netcdf file. The variable will give here. In the x dimension we'll select x, and in the y dimension we'll select y, and in the output raster it will just remain as it is. We won't select any band dimensions, and we will select the value by value. We won't tweak any other options. We'll just click OK. Now you can see a raster is visible, but this is not the specialty of a netcdf file. We can actually go to the symbology. So beside the symbology, you can see the netcdf option. Here you can see dimension values, which is time dimension, and the value is from 1971 to far beyond. So I can select any date, like say this date, and if I click OK, the raster will change. So this is just a layer of rasters or layer of values that is visualizing every date, and the data is actually represents the precipitation level of Bangladesh from 1971 to 2000. So you can actually just choose any date and it will show the precipitation level of that date. You can see every time the raster will change. This is how NetCDF actually works. This is all for today. Thank you for watching.